So this is Group A's homework. So this is not for people in Group B. Group B would be the next video. This is for Group A, and it was entitled on the board "Adding and Subtracting Fractions" video. So just adding, subtracting fractions. This is for the people who didn't have signed in the word of their assignment. So we're going to go over some examples here. All you need to do for your notes today are basically copy these examples down on your paper. So write the problem and write every step along the way, not just the answer. So we're going to start with number 1, and we have 5, just to let you know where we're going. We have 2 addition and then 3 subtraction. So just really pay attention. You've had a lot of these before, so this is review, but in the past, fractions have been difficult for students in 7th grade, remembering all the different rules and stuff. So I'm expecting some questions. So if you have any questions, just write them down, talk to me. I'll try to get with you and help you out as much as I can when we get to class. So we'll go over this, and once again, if you have questions, just ask them. One of the big things is going to be reducing and stuff like that. So make sure you're doing all that stuff as we go through. Let's look at number 1. Now, number 1 is actually pretty simple because you see like they both already have a denominator of 5. And we know that the first thing you do anytime you add or subtract fractions is find a common denominator. Well, this denominator is already common. So what we always do is keep that denominator whenever it's the same. And it will be 5. So the denominator, the bottom number, is 5. And then the numerators, you do 3 plus 1, which is 4. So 4/5. And I'll show you why here, if I can actually draw it. We'll see. Fifths are kind of difficult. Probably should have started with. So let's see. 1, 2. And ideally they would all be equal, but like I didn't plan it out enough. Sorry. So, but you can see that there's 5. 1, 2, 3, 4, 5. So 5 parts, and we'll just pretend like this are all the same. So 1/5 is like one of those parts is shaded. So let's shade 1/5, just like that. If we're adding 3/5, that means we shade 3 more of those. 1, 2, 3. Well, now we have shaded 1, 2, 3, 4 out of, it's still out of 5. Our circle didn't change and our parts didn't change, so it's still 4 out of 5. That's where that comes from, that 4/5. The denominator stays the same, you add your numerators. And then since we have 2 whole numbers here, we have a 5 and a 1, it would be 6 and 4/5. And that does not reduce, simplify, or anything, so that's our answer. Now we have an example of a problem that does not have a common denominator. So what I'm going to do is I'm going to get another sheet of paper because I kind of used my space here, and I'm going to show the work on this paper instead. I'm going to do the exact same problem. Please, once again, show your work as well. We have 1 2/5. And what I like to do with addition and subtraction is I like to copy the problems, and I like to do them vertically, like this. It does a couple of things. It makes it easier to see your denominator when you change it, but it also makes it different than multiplication. And sometimes if problems just look different, you'll know that they're done differently. A lot of times people get the rules confused for these in multiplication. So what I always tell students is always do addition and subtraction like this, vertically. And then when you multiply, divide, work them out straight across. You'll see that when we get to multiplication division. So for now, try to always do these vertically. So to add them, we need to be like this problem and have the same denominator. To do that, we need to find the least common multiple of 5 and 2. Or basically, what's the smallest thing 5 and 2 both go into? Well, that would be 10. So I'm going to come over here and write a 10. And now an easy part is to go ahead and get our whole numbers so we don't forget them. We have a 3 here and a 1 up there. You can never change anything, any fraction in math. You can never change just the denominator. If you change the denominator, you always have to change the numerator to keep it what we call equivalent. Let me show you what I mean with 1/2. 1/2 would be a circle divided into 2 parts, and we shade one of them. That's 1/2. If I want to make that tenths, I can do that. Let me draw the same circle, and in this case, I'm going to divide it into tenths. So let's see if I can manage to make it tenths. 1, 2, 3, 4, 5, 6, 7, 8. this is not perfect. Let's just go ahead and do this and this. Really, you would never want to do it this way, but it's the easiest way to show you for now. In this case, I'm going to need to say, all right, how many tenths do I shade to equal that same amount? Well, it would be 1, 2, 3, 4, 5. And once again, this probably a bar would have worked better, but we'll go with this now since we started it. 5 tenths would be the same as that. It's the same amount of the circle that's shaded. And the way we do that here is we say, well, what times 2 makes 10? Well, 2 times 5. And if we multiply by the same thing, 1 times 5, we get 5 tenths. We'll do the same thing here. What times 5 makes 10? 5 times 2. So up top, we'll do the same thing. So you notice there are 2 2's here, 2 5's there. 2 times 2 is 4. And now we'll add. So 4 tenths plus 5 tenths is 9 tenths. 1 plus 3 is 4. Notice the denominator stayed the same. We just added our numerators, 4 plus 5. That does not reduce or simplify, so our answer is 4 9/10. Any questions about that, just make a note of it. Say I need to ask Mr. Bingham or Miss Mathewson about that, and we'll talk about it when we get to class. Let's move on to subtraction. Subtraction is the same thing as what we just did. It's the same thing as addition, only now we're taking away. So it's kind of like this. Let's draw a bar this time. It's a little easier. We're going to divide it into 7 since there's 7s. 2, 3, 4, 5, 7. Let me count to make sure. 1, 2, 3, 6, 7. All right. And up here I'm going to shade 4 of those. 1, 2, 3, 4. So 4 7s. I need to take away 3 7s. 1, 2, 3. If I take those away, I have exactly 1 out of 7 left. So the denominator didn't change. All I did was I took the 4 and I took away 3, which gave me 1/7. So with subtraction, it's the same as addition. Denominator doesn't change. It still is like this. All you do is subtract your numerators, and that gives you 1/7. Let's do this one. Just like addition, I'm going to write them vertically. And just like addition, we have to have sort of a common denominator in order to do this. The smallest number 2 and 3 both go in 2. The least common multiple is 6. So we'll put a 6 and a 6. Just like before, can't change the numerator unless you change the denominator. So we have to say, well, what times 2 made 6? Well, 2 times 3. And we do the same thing up top. 1 times 3 is 3. So that would be 1/2 is 3/6. The same fraction. Well, what times 3 makes 6? Well, 3 times 2. Do the same thing at top, and that gives us 2. 2/6. Now we'll just subtract our numerators. 3 minus 2 is 1. Denominator stays the same, stays a 6. And then we have our 3 minus our 1, which is 2. And that does not simplify, so 2 and 1/6. I did not mean to make all these where they didn't simplify. It just, I guess, happened. So eventually we'll do a lot that you have to, and we'll look at that. All right, let's do the last one. Really pay attention on this one. This one's one of the tougher types of subtraction problems. So even if you got the rest of these really well, there's something here that may confuse you. So let's start at the beginning, write them vertically. All right. What's the least common multiple, or the smallest thing 8 and 2 both go into? A lot of people put 16 here. Technically, you could do that and get it right. But you really want the smallest numbers, because that makes it easier. And since 2 times 4 makes 8, 2 goes into 8, your smallest number is actually going to be 8. And, well, let's see, 8 times 1, so if we multiply, that would actually just be 1. If the denominator doesn't change, the numerator doesn't. 5 and 1/8. What times 2 makes 8? 2 times 4. So 1 times 4 is 2 and 4/8. So hopefully you've noticed the problem. Unfortunately, a lot of people don't notice the problem with this. A lot of people do this. They say, well, 4 minus 1 is 3/8, 5 minus 2 is 3, and they miss it. You cannot do that. You have to look at this for an extra second. See if you can find the reason we can't do that. if you notice, this is a 1, and it's on top. The 5 is bigger than 2. It's also on top. I can't say 1 minus 4. Now, I could, if this were smaller, we could talk about that, but let's not go into that yet. We really can't do 1 minus 4 right now. So, there are a couple ways to do this. One way is to just borrow 1 from the 5, make the 5 a 4, and so on. That's really the best way. So if you know how to borrow with fractions, I much prefer that way. But if you've gone this far and haven't learned it, you're not going to get it from this video, so I'm going to show you a different way that's technically harder, but sometimes it's easier for people to understand. I know that doesn't make sense, but that's what I've found in my experience. It's harder because the numbers get bigger. It's easier to understand because it's more familiar. So we're going to do it the second way. But if you'd like to talk about borrowing with me, come ask me and I'll talk about it with you and see if you can figure it out. The other way to do this, I'm going to switch colors so this stands out. Since you can say 5 minus 2, but you can't do 1 minus 4, what you can do is make this fraction improper. And remember, to make a fraction improper, you multiply and then add. You work from here up. That should be review. If you're confused about that, just call it to me and I can help you with that some more too. What we're going to do is say 8 times 5 is 40, plus 1 is 41, and that would be over 8. 41 over 8. And then I'll have to make this one improper as well. Multiply and add. 2 times 8 is 16, plus 4 makes 20, over 8 as well. Now I fixed the problem, because I can do 41 minus 20. I couldn't do 1 minus 4, but I can do 41 minus 20. So you just make them improper is one way to do it. 41 minus 20, I'll do it over here. You may just be able to do it in your head. Let's just do it here just to make sure. It's 21. And then the denominator always stays the same. Technically, there is nothing wrong with leaving a fraction improper. As long as you've reduced, that means you've divided by common factors, you can leave it improper. So this is technically correct. You could also take that, since these are mixed numbers, you could go ahead and convert this into a mixed number. This is something we'll just practice this a bunch in class at some point, but the way to do it just quickly, without making the video too long, is what you would do is, how many times does 8 go into 21? Well, it would be 2 times. So 2 is the whole number, the 2, which is 16. Then you subtract, you get 5. So there are 5 left over. So to recap, I've said 8 goes into 21 2 times, that's the whole number. 2 times 8 is 16, which makes 5 as a difference. You take this 5, that becomes your numerator. Remember, when you do these things, the denominator doesn't change, it stays this 8 here. So it'll be 2 and 5/8. So really either of these answers is right, depending on the kind of problem you are doing. If this is like a short answer thing where you're answering things, I'm probably going to give you credit for both of these. If it's multiple choice, it could be either one. It won't have both answers, but you'll have to be able to find one or the other. So this was a lot. Fractions are historically very difficult for students, so please come with questions. I hope you wrote some stuff down, but come ready to ask some stuff so that we can help you out. And we'll try to talk about it and get all your questions answered in class.